Oh, hello. We are back again. Today is 25th of November, and we are back here with another November challenge. And today we need to find a integer which consists of only one, and we need to which is divisible by k. So k is just a integer that is given to us here, and we need to find a number so that consists of only one at ones, at tens, at hundred place, and which is divisible by k. So let's take some example which using which we can understand pretty easily. So if k equals to 1, the simple answer is 1. So if k equals to 2, uh, see, we can clearly see that a number which is a multiple of 2 would never, or maybe if you add 2 n times, then that number would never end at a 1, because even number and 1 is not an even number. uh, Hence we return -1 if it's not possible. And again, for k equals to 3, we return 3 because the number divisible by 3 is 333. You can clearly see that 1 plus 1 plus 1 equals to 3, so 3 will divide this number. Now, the first thing, before going on to checking if finding that integer n, let's first see that if that integer exists or not. So in this case it exists, in second case it does not, and let's continue for more cases. So 2, it will never exist, because we know that no term containing true will ever end with a 1. It will always be even, so we don't need to check for 2. For 3, we checked if it exists. And for 4, 4 has 2, so 4 is even. So you multiply any number with it, like be odd, even, the number will always be even. And since 1 or any such number cannot be even, all the even numbers in the whole number level in the whole number series are discarded. No, if k is even, we know that uh, it won't be able to divide such number ever, so answer is -1. Let's check for 5. So what happens with 5 is that 5 multiplied by any number will end in 5 or 0, and we know that since this number won't end with a 5 or a 0, we know that 5 would never be able to do this. 6 is a even number, we don't need to worry about it. 7, let's find out for 7 if it can or not. 8 is also even. 9 can divide the same number, this 111, the same as 3. And 10, even number, we, and obviously a multiple of 2, so, well, a multiple of 5, so we don't need to worry about this. So our first case will be when to return -1. If that number is, let's say, even or is a multiple of 5, then we can clearly say that it will never end with a 1, so the clear answer is -1. What if it does not? Then we need to find such number, and finding such number can be a tad bit difficult, but we have a simple thing. Check with 10, check with 1, check with 11, check with 111, check with 1111, and so on. So let's forget about the condition to where to stop. First, let's form the condition to how to multiply a number and make it 1, 11, and so on. So for doing this, start a number with 0, multiply that number by 10, and add 1. Simply by doing this, the first number would be 1. Then as the number is 1, so 1 into 10 will become 11. 11 will become 10, and as we add 1 to it, it will become 11, and so on. And since it is given that the n may not fit in a 64-bit signed integer, so whenever you hear the word overflowing or not fitting into a particular data type, there are only two things you need to think about: using long int, and the second thing is using a modulus. Because if it does not fit something, you can always take a modulus of it. So if I take the model, see, you all know that a into b plus, where's the plus c, the whole modulus. I'm clumsy today, don't know what's happening. The whole modulus k is equals to a into b modulus k. I'm so sorry. Modulus k plus c modulus k, the whole modulus k. So by this property of a modulus, we can clearly see that if we take a modulus of a number and then do the same thing, then also the number will remain same. For example, let's do it with 7. Our k equals to 7. Now firstly our number is 0. Okay, so what we need to do is we need to add 1 to it and then check if its modulus is k or not. So let's add 1 to it, it becomes 1. Modulus 7, it gives us 1 itself, it is not 0. Then do with the same with 11. Modulus it with 7 will give us 4. What if we are not taking a mod here and instead we have a condition here that if this condition is true, then what happens? So we are taking both conditions simultaneously. If this happens, it is 11 right now. The next, if we don't take the mod, it will become 111. But if we did take a mod, it will become 41. And then again, it will become 111, and we'll again check if it's 0 or not. And in this case, it will become 41, 36, 61. Then again 1, and this will become, we have 551, and then again 1, and again we have a remainder of 2 here, so it's 21, and we can clearly see that 21 is divisible by this. So this and this, so if we take a modulus of this and we take a modulus of this, they are virtually the same thing. So it's it's easy for us to take a mod here and not increase the number like this, and just make that number of a constant space. Second thing here is when to stop. When do we need to stop? So it's clear that the number of remainder for a number k will always be from 0 to k minus 1. So if this loop runs for k time and does not return a number, still does not stop, it is clear that the number of remainder are repeating now. So if they are repeating, then clearly there is no solution for this. And this is a simple question, easy to do, and wasn't much trouble. Thank you.